In this video, we're still going over and talking about normal distribution here, but just a little different than from before, being able to use what was called our empirical rule. Because empirical rule, right, make sure that you remember. So if it's exactly one standard deviation above or below away from the mean, then you're talking about 68% of the data. So 2 standard deviations away was 95% of the data, so on and so forth. So remember those key amounts here. So like, for example, we're saying that the tests are normally distributed with a mean of 75. So remember our mean, right? So our mu would always go in the middle here with a standard deviation of 8. So sigma here is 8, so that means one standard deviation above is 83, then 91, and 99, right? Then below is 67, and then 59, and 51. However, notice the question says we're going to find the probability that a randomly selected student scored between a 71 and 75. But notice 75 is here, but 71 is not. 71 is somewhere here, right? It's below the mean, but not necessarily one full standard deviation. So we're not just going to go, oh, I think it's this. We're going to calculate. So when you don't have the amounts here on our normal distribution curve and not able to use empirical rule, we are going to use these steps here. So we're going to set up our normal distribution. So notice how it says we are going to type normal dist. So just the normal dist, and you'll see what happens, and then open the parentheses. So here we're going to go into Desmos graphing calculator. So make sure you open up so that you can see. So again, we're going to type normal. See how it's italic? Then DIST for distribution. Then notice how it changed. That's how you know you're correct. Then notice you need to open the parentheses, and then there's your information. So notice here, we are going to type the mean first and then the standard deviation. So again, here, notice, and here's that reminder. So the mean was 75, so 75 comma, standard deviation of 8. Then we do need to click on the cumulative probability. So we're going to click here. Now, don't do anything else. We're going to leave it. But now, like with the region and the compute, so we're doing all of that because we're finding the inside area. So now we've got to figure out what are we talking about here. So there's this concept of the minimum, which is the lower bound. Well, we're going 71 to 75. So this is 71 to 75. That is what we're trying to find the probability of. So that means here we are going to have 71 as our lowest and 75 as our highest. And that is the probability, 0.191. So that here is 0.191, which is about 19.1%. So that is a probability of choosing a student between a score of 71 and 75, okay? So here, remember these steps, and we'll go through it again. So let's do the same thing. We're going to still test our normally distributed with a mean of 75, standard deviation of 8. So then here we're going to estimate the probability that a randomly selected student scored higher than an 80. So that means, again, we still have the same mean and standard deviation, but if I want to know scoring higher than an 80, then that means the lowest score is an 80. Then for accuracy, that means we're going above that, right? So we're going to use infinity. So this is how we do this. So here, let's go through. I'm going to exit out. So let's practice again, right? The steps. So what do we have to do first? Type normal dist, right? Like normal distribution, and open the parentheses. So here, type normal dist until, there you go, open the parentheses. Then again, there's your reminder, right? Mean first, then standard deviation. So 75,8. And again, click on the cumulative probability. So again, remember, we want to know scoring higher than an 80. So 80 is the lower bound, the lower number, and then the upper bound. So the lower bound here, so it's going from 80. Notice how it automatically, the computer, your graphing calculator, goes to infinity. That is the probability of getting a student who scored higher than an 80. That is 0.266, which is about, so again, 26.6%. So here, we're going to do another one. Same thing. We're going to use the same mean and standard deviation, but we're going to figure out the probability of selecting a student who scored less than an 87. So now that means 87 is the highest score because we're looking for someone who scored less than that. So we're going to leave that lower value as negative infinity. So again, we've already got this set up, and then we're going to put here our 87. Notice how it automatically goes here, that lower amount, to negative infinity. So here's our probability, 0.933 or 93.3%. So again, here, that's how we're going to calculate. So let's do this example 2. So again, just the reminder, right? Normally distributed with a mean of 150 and standard deviation of 36. So here, notice that this is going to be another because 150 is the mean, then one standard deviation below. So 36 is 114. Then I would subtract another 36. Notice is 100 on the bell curve. Is it part of empirical rule? No. So again, that is a sign that we're going to have to calculate. So that means here our mean is 150. Our standard deviation is 36. Then our lower bound and our upper bound. So if we want to know probability of at least 100 inches, that means the 100 represents what? The lower amount, because we're going to go greater than that. So our upper bound, we keep it at the infinity. So here, pause the video and let's see if you remember how you would put this in the Desmos graphing calculator. So go ahead and pause the video. And here we go. So normal distribution, then our mean is 150, right, comma 36. So there's your standard deviation. Then click on cumulative probability. So then here, right, remember that lower amount, at least 100, and boom, notice how it automatically goes to infinity. So here's your probability, 0.918. So here, 0.918 or 91.8%. So then here, same thing. Notice our lower bound, upper bound, though, need to be set. And this one's nice because it's between 200 and 300. So the lower bound is, we're going 200 to 300. So then here we go. So we're going to go 200 to 300. And there is the probability of the amount of rain. So that means here we've got 0.082 or 8.2%. So here, pause the video and try these U-Try questions here on your own. And here we go. So for this first one here, the average, or the mean, was 432 with standard deviation of 36. So because we're looking for the probability of more than 450, That means 450 is the lowest. We want more than that. And so the upper bound was infinity here. And this one, all the same. And this one was nice, between 400 and 440. So 400 to 440. Then this one here, same mean and standard deviation, no more than 375. So this one, you had to set up the highest amount is 375. So we're going down to negative infinity. So again, just to make sure for the first one that you had the 450. So here's your setup, right? Normal dist with the mean, comma, standard deviation, and the lower amount was 450. Notice again here, you should have gotten 0.309. So this here was, so 0.309, which is 30.9%. That is the probability. So then here you should have gotten 0.401 or 40.1%. And then here 0.057 or 5.7%. So then here again, pause the video and try the second one that's in multiple choice format on your own. And here we go. So here you should have noticed, now just a heads up again, why we're not able to use empirical rule. The mean was 65,000 with a standard deviation of 6. So one standard deviation above is 71. Notice how 68,000 is not part of the empirical rule. So we would have to estimate. So here we go. So here's your mean, here's your standard deviation. What is the probability of making at least 68,000? So that means that was supposed to be the lower bound of 68,000 because you're going above that and leaving that to infinity. So then here's your setup. Do not put the comma in the 65,000 and 6,000 because the comma is what's used to separate the mean and standard deviation. So 65,000 and 6,000, and here's that lower bound to infinity. So that's why here the answer is A.